welcome to my live stream. Okay. Just trying to get my free screen juggle to work. Sure, there's a voice there. Yep, that's pretty good. All right, welcome to the Cannibal solar flare discussion. We're using the term cannibal a little bit whimsically, but that's something we've been calling it at the moment. So starting from the top, NOAA did issue this a G4 warning, or G4 watch they call it. It's the first since 2005, which rather surprised me, but I guess that's correct. So they're expecting if they've released a watch, and also they're going to hold a conference as well. So they must, which is this one here. So I don't believe I've ever seen anything like this before. Whether this is something new they're going to do, or they just think the event is going to be that strong, they thought they better hold a press conference about it. It's all rather interesting. Hi, Sonny. So I'll just try to get the what's been happening is this area on the sun has been flaring. So they've got a picture of the flare right there. So it's just what they call an active region, also known as a sunspot or sunspots, depending on what terminology you want to use. So that's where it's been coming from. Now, the flare itself was fairly energetic, but it wasn't that remarkable. What is remarkable is this other thing that I'm about to show you. I'm trying to get right to the punchline straight off, if you know what I mean. Where have they hidden this one? Down here. Right. Oh, g'day, Les. Welcome to my my off-the-cuff live stream. So to get right to the punchline, this is why we're calling it a cannibal event. You get 1, you get 2, you get 3, you get 4 CMEs. 3 of them are going to eat each other. And what happens when that happens is they can become stronger. That it's not necessarily that they will, but there's a probability they will become stronger. So that's why we're calling it this one a cannibal event. So if you have a look, going back here, this is when they expect it to arrive, which is sometime tomorrow, my local time. The speed itself is Sonny, is that dangerous? No danger whatsoever. If the way I describe it is good. Thanks for the question. Yeah, I should have said this up front actually, because some of the headlines look a bit alarming, but it's just headlines. Don't worry about it. The way I put it is if the average person wasn't told this was going on, they would never notice. They would never notice it. So there's no danger. There's no danger to anyone from this event. So what's remarkable about it is the speed itself is not remarkable. It's about still below about 1,000 kilometers a second, but what is remarkable is the density of the plasma. That's quite high. So, and that's a result of the cannibalism. That's because of the free coronal mass ejections have joined together. So they don't go any faster, but what they do is they get thicker, and the thicker a coronal mass ejection is, the more magnetic field it can potentially hold. So that's what the excitement all about. It's that black line just there. All right. So What else is important at the moment? Not a lot, because it's early days yet. Like I said, it's due in tomorrow. It'll be interesting to watch the. I'll be watching the NOAA conference tonight to see what they say about it. If they say anything interesting, I might react to the conference. Yeah. So the storm itself that they're forecasting. This is usually your best diagram here. The time is now around about 9 a.m. UTC. So we're about there. So we've got a few that's 3, 6, 9, 12. 15. Yeah, we've got well over 12 hours to go yet. So things may develop, but this is a line here that's interesting. That's a if it gets above 8, that's basically that's where the G4 level storm watch is coming from. So you'll see between this period of time, that period of time, it's got the potential to be rather strong. Now, there's something important that you have to understand about these forecasts is they tend to give a worst case scenario for how strong they think the storm's going to be. I'd say the rule of thumb is it's about a 50% chance that will actually happen. The reason being that the magnetic fields may not line up correctly to produce a big storm. So, and that's a rather, without going into all the technicalities, that's a rather 50%, around a 50% probability of that occurring. So just if they have to give the worst case scenario, right, that they think. So if it doesn't reach that, don't think they're incompetent or anything. It's just it's like weather forecasting, all you can do is give the odds for a particular event occurring. Yet there's no certainty in this forecasting business. So that's what they're getting excited about here. Now, me being me, I like to get confirmation from somewhere else that I think all this is developing. So I use a little trick here. I go to something called the EPAM-P, which is on the A spacecraft, and there it is. That's a indirect evidence of an approaching coronal mass ejection, and it's got the potential to be a large one, just from how clean that signal is. You can actually use this to predict when the thing's going to hit the Earth too. So it's nowhere close yet. But what will happen? I should have actually. I didn't prepare the graphics. Sorry, I should have prepared it. I'll just demonstrate it. Can you see my cursor? Yeah, you can see my cursor. What will happen is when the coronal ejection is about an hour's away from the Earth, this will go exponential. It'll climb very quickly up to maybe here, something like that. So it's very clear when it does. Les in the density at the moment. What currently you mean? Just keep in mind there's a 30-second latency on YouTube. By the time I say something, it takes you 30 seconds to hear it. So the density, that would be that one. It wants to switch over for me. Why is it? Oh, there we go. All right, let's have a look. Yeah, I think Les. I think what's happened is there's another There's another CME coming as well, a smaller one from some other things that have been going on the sun. So that could be a different event. So it's possible. Yeah, the density has in the solar wind has indeed risen. You can see that quite clearly right there over the last 24 hours. That's increased, but you know the density of solar wind goes up and down, depending on the Parker spiral and stuff like that. Yeah, no, that's true. That's true. But we're expecting it to get a lot higher than that, much higher. If that Cannibal CME comes in the way they think it might, it's the density is going to be off that chart. Anyway, so the yeah, where the let's get back to this guy again. Yeah, so it'll go exponential. It won't go straight up, but it'll just start to climb very rapidly. And it's a good way to tell that what it means is the CME has passed over the ACE spacecraft, and the ACE spacecraft is between the Earth and the Sun. So it's closer to the Sun than the Earth is, so it tends to get the effects before the Earth does. So it gives you about an hour's warning, approximately, give or take. So if you're the sort of person who likes to watch gauges and get indirect confirmation of things, this is a gauge to watch. The old ACE spacecraft still chugging away out there. It's almost out of fuel. It's almost dead, but it's been out there for a long time. Yeah, so definitely something is coming. Something is coming. What they can't basically predict is how strong it will be and what its effects will be, because it depends on a couple of different factors. Which I won't go into because it tends to get a little bit complicated. I'm just trying to think if there's anything else that's really important at the moment. No, it's after we hear this. I want to watch this media thing, which is on when are they scheduled it? Published 10 a.m. at Eastern Daylight Time, so it'll be in an hour or two. Not an hour or two. No, it's not. It's not for a while yet. It's late. It's later. It's only about 6 a.m. in the morning. So it's another 4 hours for this conference. So I recommend you hang around for that if you're interested. I'll just go back to the yeah. At this point in time, there's not. Oh, there's what? Sorry, there's one other thing I should show while I'm at it. Right here. Yeah, this is what they call this is what's kicked it off. These events on the sun, these what they call these X class solar flares, and we've had several over the past couple of days, and that's what's produced the 4 or 5 coronal mass ejections. Yeah, I'm getting some chat here, so just hang on, just give me a chance to read the chat. Okay, no one's really answering, and no, okay, no one's okay, look, no one's actually asking a question exactly, so I can only answer a question that's actually a question. If it's just a comment, it's just a comment. Go ahead and comment if you want, but I'm not going to try to figure out a question from your comment. You have to ask me a specific question that I can answer. But go ahead and comment if you want. That's fine. Persid, that's a question. No, no, X-Files aren't dangerous. X-Files aren't dangerous. If nobody was telling, if nobody was telling you about it, you wouldn't know that it happens. So yeah, no, I'm not concerned about anything that I see here. But even if I was, I'd keep my mouth shut and let the official people talk about it. So the fact that I'm here talking means that I don't see any major effects from any of this. Look, sensitive stuff like satellites, power grids, stuff like that, they can be affected to a certain degree, but it's not as if this sort of thing hasn't happened before. They follow their procedures and they know exactly what to do, and it's happened many times before. So I don't see this as being a sort of a 1 in 100 year event or 1 in 500 year event or anything like that. This is pretty normal. I'd say you get several of these type of events during a solar cycle. So I don't see anything concerning here. And I think if I did see something concerning, I would keep my mouth shut anyway and let the authorities do the talking. But we're not in that situation today. Not dangerous, no. Um, Ian, I wouldn't be concerned about it. A G4 storm. We had one in March. I mean, we had one in March. It produced a lot of pretty lights in the sky that people went out and took photographs of. But there was one. I think they did. I checked afterwards, and there was one power surge somewhere in Canada. Places like Canada, North America, and that tend to get affected for some reason. Something to do with the rock they're sitting on. But they had a bit of a surge. But hey, they know what to do. It happens. There's a lot of other weird things that happen with the power grid as well. Hot days are probably more dangerous than these things. You get the power line sagging towards the ground and stuff like that. That's a lot more serious. Not a lot more serious than a geomagnetic storm. Uh, oh, okay. New boy, you're answering his question. Yeah, no, that's good. That's good. Let me just have another quick look. Yeah. Oh, look, I got to keep saying it. It's not. That's one reason I do this stream is to try to counteract some of the fear mongering that goes on. I people want clickbait headlines and titles and stuff like that. Go and watch their videos. They're good entertainment, but don't give anybody any money. That's what they're after. They're after donations. Just don't. They can get your view, and that's it. That's all that they're justified in getting. I'm not monetized. I don't ask anybody for anything. I don't try to sell you a t-shirt or a coffee mug or anything like that. This is one reason why I do this. Do some of this stuff. Okay, Frank, do you see the EPM protons start falling just before the CE arrives, or well, it goes exponential just before the CME arrives, and then it will trail off. It will decay after the CME passes by. If the CME has missed the Earth completely, it'll peak and then drop off, and we just won't see anything. Does that answer your question? And oh yeah, look. You're quite right. People, anything weird happening, people are just going to blame the solar storm, aren't they? Oh, if they want to do that, go right ahead. But usually it's the amount of coffee they've drunk or their diet or something that's a problem. Not the solar storm, but it's just two random events that people get linked together in people's minds. So it's you can have a laugh about it, but there's nothing there. There's nothing there worth talking about. Okay, so what I wanted, okay, that's the X-ray. So that's what's produced this thing. I was hoping we get, it might have scrolled off by now, but let's have a look. See if we can see these CMEs. I can see them. There you go. Yeah, we've got a couple there. I'll try to highlight what this is. Those things are planets, by the way. Don't be alarmed. That's the sun. There, those are planets, right? Probably Mercury and Venus usually. Yeah. So what's happened? You can just see this. You've got to sort of use your imagination a bit. If there was a bubble heading straight towards you, what would that bubble look like? It would look like a circle that gradually gets larger, and that's exactly what's happening here. So we're looking straight at the sun, or actually the satellite's looking straight at the sun. It's one of the ghost satellites, I think. Actually, no, it's not. It's not the ghost satellite. Can't even remember which one it is these days. It might be. It's coronagraph. I can't even remember. Oh, I can't even remember which satellite it is. That's how I'm a bit rusty at the moment. But so they call these things a halo. Now, the more circular the halo looks, the more likely it is that it's heading towards the Earth. So if you can see this one, it's a bit lopsided. You've got a bigger bulge coming out this way, and you've got a smaller bulge coming out that way. That means it's actually off to an angle slightly relative to the Earth. If you tend to, ones that are heading straight to the Earth, you tend to get a perfect circle that goes like that. So they might even call that one a, oh no, it's not a, no, that's a full halo. Yeah, sometimes they call them asymmetric halos. It means it's a halo on one side, not a halo on the other side. But that's the way they can measure. What they do is, I believe, is with each frame they measure a number of points around the edge, and then go a few more frames, measure the points around the edge, see how much they've moved, measure them again. And by applying an appropriate computer model, you can get estimates of speed and stuff like that. So that's pretty much the. Oh, thanks, Les. That's pretty much what they do. It's all science, but you know it's easy to understand. So it's just nothing sort of genius about it, really. It's just applying what they know about physics and engineering. What's hard to get through is the jargon more than anything else. Once you get through the jargon, it's there's nothing difficult to understand. The old term about it being rocket science. Well, it is a kind of rocket science, but yeah, we got a new one just coming out now. That would have been from the from that solar flare there. So it's produced another one. So now that's number 6. Will it actually catch up with the other guys and cannibalize them? Maybe it will. Maybe it will. It depends on how fast it is. I think at this stage they won't be able to estimate. They'll have to wait a little while before they can estimate its speed. I wish I could remember the name of the satellite now. I feel a little bit embarrassed. I can't remember where the coronagraph. I'll put that down as a question. I've asked myself. Coronagraph. Satellite space station. TE. All right. Oh no, that's all right, Ian. That's okay. No, it's everyone just does their best with a 30-second latency. So that's it. Pretty much. It's just going to be a waiting game. To see what happens. It's definitely coming. I'm 100% certain about that. What they can't predict exactly is how strong it will be. So they tend to give it give a bit of a worst case scenario. And I'm interested in this this conference that they're going to have. That's unusual. I don't recall them ever doing that before, but then again, maybe they have and I just missed it. All right, so we got any questions? I'll wait a couple of minutes for any questions. And if there's no questions, I'll just wrap it up. What is the name of that ruddy satellite? Can't remember. Honestly, cannot remember. Would it be Soho or it's probably Lasco. It's probably Lasco. It's got to be, considering that's Venus and Mercury. It's a lot closer to the sun than we are, so it's a bit closer to the sun than we are. So it could be Lasco. Have you heard of people feeling affected by the solar activity? No. No. If people want to believe that, hey, look, I don't stomp on people's beliefs, but I think it extremely unlikely. The reason being is this is all happening out in space, and we're not out in space. We're under an atmosphere several hundred kilometers thick, and after the atmosphere, that we've also got a magnetosphere that tends to deflect a lot of this stuff away from the Earth anyway. So our magnetic field of the Earth goes out into space quite a long way. That's why even people in the space station are quite safe from these storms. Because even though they're about 170 kilometers up in orbit and they're outside the atmosphere, they're still well within inside the magnetosphere. So they're protected by the magnetic bubble around the Earth as well. It'd take a really big storm to concern the people in the space stations. So I'm sure they got their plans and contingencies and that. I don't know what they do, and maybe they don't tell anybody, but they're sort of I think they're classified as radiation workers. So obviously there's some radiation up there that they need to be concerned about. I think they're actually classified as radiation workers, but they're usually safe because they're within the magnetic bubble that the Earth's in as well. So what I'm saying is none of the effects really get through to the Earth. What happens is when you get when you get the northern lights or the southern lights, it's still happening hundreds of kilometers up in the atmosphere. What actually happens is it's this you can see the gas. It's a plasma, but it's also a gas. What happens is it's when it reacts with the Earth's magnetic field that produces the northern lights and the southern lights, and that's the only time really that and the magnetic field flips around. But unless you're a pigeon, I don't know who the magnetic fields are just too low to affect people. I mean, a fridge magnet is much more powerful than those magnetic fields. Now, the reason why power grids and that may get affected, it's because they're in effect wires that are hundreds of kilometers long. So they have the ability to pick up a lot of the magnetic field, just because they're just so huge. But it's because they're so large. They're hundreds of kilometers long. So you can get fluctuations in the magnetic field. It induces currents into the power lines, but on the scale of a human being, and also we don't have any wires inside us, at least I don't. Extremely unlikely that there's any effect on human beings. It's the indirect effects that, well, you know, if the power goes out somewhere, well, that obviously affects people. So that's something they have to worry about. If it goes and knocks out the GPS system, well, that could be it could be inconvenient, but you know, not necessarily dangerous either. If it could even affect the GPS system, I'm not quite sure. Okay, yeah. Oh, thanks, Ian. That's cool. Yeah, sorry, I should have been wrapping up. I was just rabbiting on. All right. So I was asking for questions. So many CMEs. How the energy field, it recovers. It, you know, you can get, like I said, the effect is the northern lights, the southern lights. That is the effect of the coronal mass ejection hitting the Earth's magnetic field. So it can persist for a day or so, perhaps. You know, I'm just poorly making up figures, but it depends what you mean by effect. You know, but clearly the effects do persist for a while. It's probably because these clouds are so large. They take a, you know, from one end of one side of the cloud to the other. Probably takes a whole day to get across it anyway. But yeah, so there's a little bit of an effect there, I guess. But you know, the northern southern lights, they're hundreds of kilometers up in the sky. They're up in what they call the ionosphere. So you know, I better wrap it up. Absolutely no, I don't see anything concerning about this one. You know, it's not, it's, you get a couple of these events during each solar cycle. They know if they do get a spike in the power grid or something, or satellites get affected, they know it, they know what to do because they've done it all before. What I do recommend is you go and listen to the NOAA conference. They're the experts, so I'll be listening to hear what they say. But if I was actually concerned about anything, I would be keeping my mouth shut. And but I reckon that's never going to happen in my lifetime anyway. So it's just you know, an interesting event, and some people might be lucky enough to see pretty lights in the sky, and that's it. Yeah, Ian. I'm zero concerned. zero concerned. Okay, catch you all next stream.